Now, before we do the trigs, we're going to learn three kinds of shortcuts. So, three shortcuts in U-subs. And number one, integral of f prime of x, f of x to the nth power dx is f of x to the n plus 1, 1 over n plus 1 plus c. So the way you understand this is, think of d of f of x. What's d of f of x? F prime of x dx. Right. So you can rewrite this one as think of this times this as integral just like that. Now once you take this approach, now you can think of this f of x as some single character, right? So it's really like what? A to the nth dA, something like that. How do you do the antiderivative? It's just the power rule, right? It's just the power rule. What's the power rule? Add 1 to the exponent, put the reciprocal in front. That's a power rule. Okay? And therefore, what does it mean here? It means exactly f of x to the n plus 1. You add 1 to the exponent and put the reciprocal in front. That's why it works. Now, this can be a real time saver because, for example, if you have an integral of, say, sine of x, cosine of 3x dx, then what's the derivative of cosine?
Sine.
Negative sign. So you want to put a minus in front, but it's not there. So what do? You make it happen. But if you put a minus, there's no way these two are the same, right? So you have to put something in front. What should you put in front? Put a minus, right? Put a minus in front. Then are these the same? They are, right? They are the same. But why would we want it this form? Because this is the derivative of cosine. So it's exactly this form, right? And there's a minus, so be careful. So there's a minus somewhere. Okay. So according to this, what should be the antiderivative? Cosine to the fourth power. Right? You add 1 and 1/4 plus c. Yes?
The A is down here in this one. That's just a placeholder, right?
Yeah. So I was just pointing out that this is true with A being a placeholder.
Okay.
So if these two match, what's the power rule? You just add 1 and put the 1 reciprocal.
Okay.
Now there's a specific form which is more often used than the others, which is if you have a product of the function and its derivative, what would that be? What's the integral of this? This, you can get this the formula for this from here, right? So for us to use this formula for this specific one, what should you let n equal to? 1. N is 1, right? So what do you get on the right side then? 1 over 2. Fx to what power? second power plus c. Let me show you that example. And let me show it in two. Let me compare two different approaches to the following problem. So example 1. Let's say you want to integrate tangent of x times secant squared of x dx. And let's say you didn't have any idea of how to solve this. Well, in that case, you can just convert everything into sines and cosines, right? So you can rewrite, so here's method 1. You can rewrite this as sine over cosine. And secant is 1 over what? Secant is 1 over?
Sine?
Nope.
1 over cosine.
Cosine. Okay, secant is 1 over cosine. You get this. And then you end up with a similar situation as before. So you have sine of x times 1 over cosine cubed of x dx. Because cosine times cosine squared is cosine cubed. But then you see, again, the derivative of cosine is negative sine, so we use the same trick that we just did before, which is negative of negative sine of x. And we're going to rewrite this as cosine x to the negative 3 power. So that now this form still looks like this one, right? Yes?
I'm still kind of confused about going to the trick for like the negative thing. I know you did before, but how does that get rid of the sine x? The sine x disappears when you integrate.
So the question was, how does this trick get rid of the sine x when you integrate? Well, first of all, you see that in this formula, f prime disappears, right? Why does it disappear? Because this is an artifact of the chain rule.
Right.
So you remember how we...
Substitution.
Yeah, so we're doing the... In a sense, we're skipping the u substitution. So we're undoing the chain rule, right? When you undo the chain rule, the artifact of the chain rule disappears when you undo the chain rule, because that was created by the chain rule. When you undo the chain rule, it disappears. Okay. All right, so if I apply this formula here, what do you get? N is negative 3, right? So it's negative 1/2 cosine to the negative 2 power plus c. So it's going to be positive 1/2 1 over cosine squared of x plus c. And 1 over cosine is secant, so it's 1/2 secant squared of x plus c. But here's a quicker method, method 2. If you have noticed that tangent prime is secant squared, so if you differentiate tangent, you get secant squared. Now, a person that knows this has an unfair advantage over the other person who doesn't know it, because this immediately tells you what form is this? This is like the function times its derivative, which is exactly this one, right? So what's the antiderivative then? If a function is multiplied to its derivative,
You've got 1/2 secant squared.
1/2 to the function squared. Or just, let's put it like that. Plus c. Done. No transformation, nothing to do. It's just there. Immediately. So it's a lot faster. Okay. Now, here's another interesting thing that you see after solving this. Is secant squared same as tangent squared? No, they're different, right? So does that mean one of these are wrong? Actually, these are both correct. The true answer is that tangent squared plus 1 is secant squared. So they are off by a constant.
Oh, and that's covered by the plus.
That's covered by, so these two C's are different. So you could say this is C1 and that's C2. And I think C2 is 1/2 more than C1 or vice versa. It's a little confusing, but that's how it works, okay? All right, number 2. If you integrate f prime of x over f of x dx, can you guess what this would be? What would be the antiderivative of this? It's very similar to this idea, right? Any guesses? ln. See, remember this? X to the n dx, the power rule is this one, but there is one exception to this rule. For what value of n is there on the exception?
1.
When n is -1,
No.
there's an exception because you get 1 over 0. Right? So if n is -1, what do you get instead? X to the -1 is 1 over x, whose integral is ln. Okay, so that's the exception. That's what this is doing. Okay. So this one really does look like this one with n being -1, but this is the exception where you get the ln. Okay, number 3, I should give you an example. So, example 2, say you want to integrate cotangent of x dx. This is cosine x over sine x, right? But if you look at it, if you differentiate the sign, you get cosine, right? So it has the structure of f prime over f. So what's the antiderivative? ln of the denominator. So you can just apply this and simply get the answer. Okay, number 3. I think I already showed you the examples of these before, but the number 3 is something that you haven't seen before. So I'm going to write it down, but you might not understand what I wrote down until you see an example. Okay. So let's say you have integral of f of x as capital F of x plus c. In other words, let's denote by capital F of x the antiderivative of the small f of x. If you have that, then integral of f of ax plus b dx is going to be 1 over a capital F ax plus b plus c. So here's an example. If you have an integral of sine of 3x plus 5 dx, what does this formula say? Well, first, you have to figure out what the antiderivative is. And you're going to just use the same antiderivative, but there will be a 1 over a in front. So let's think about this. What gives you the, what is the antiderivative of sine? Negative cosine, right? It's negative cosine. So you need the negative of cosine. But according to this formula, whatever you write here is same as this. So whatever you write here is same as this one. And you put the reciprocal of this number in front. You put plus c. Yes?
I have a question. I forgot what a big L f of x represents.
Big F x is a negative cosine here. It's the antiderivative.
So over there on the thing that.
So it's the same antiderivative, same thing inside, but you need a 1 over a in front. That's what it means.
Oh, okay.
Let's try another one. Integral of e to the 4x minus 1 dx. What's the antiderivative of e to the x? E to the x. So what do I put here? Same thing. What goes in front?
Reciprocal of the first
4.
digit, so 4 over 4.
Okay. Now, the interesting thing is, plus b has no effect. Right? It does only the number in front of x, that gives you this 1 over a.